Hey everyone, welcome back. So today we'll be discussing about bias variance trade-off. Okay, so what is mean by bias variance trade-off? So this topic related to overfitting and underfitting. Okay, so let us discuss. So what is mean by bias? Okay, just bias. What is mean by bias? Bias is nothing but error due to wrong assumptions. Okay, error due to wrong assumptions. Wrong assumptions. Okay, this is known as bias. This like the error due to wrong assumptions is occurred when the model is very simple. When the model is very simple, model is very simple. Okay, so a case where we have to use polynomial regression, we have used multiple linear regression. Here the model is very simple, right? We need to perform a third degree or fourth degree, but we have used only 1 degree. All right, the multiple linear regression looks like a beta naught plus beta 1x plus beta 2 and so on, right? The degree of the multiple linear regression is 1, but when the data set is like let us suppose you have a cos or sine. Okay, the data looks sine, the data looks like this, right? When we use polynomial multiple linear regression or simple linear regression, the data will be like this, right? the the line will be like this, because it is the only line where the error is much low compared to other lines. Because of this the model is very simple, right? Because of this the error becomes more and more. So to reduce this, we must use some complexity, right? We must have some complexity. When we use polynomial regression, the bias reduces, because we have there is no error, right? You can see when we use polynomial regression of a degree 2, then it works like a sine. This is known as bias. Okay, I will explain you in much easy way, okay, in the video. Okay, just hang on. So what is mean by variance? Okay, what is mean by variance? This is error due to sensitivity. Okay, error due to sensitivity. Here the opposite of the bias, that is the model is very complex. Okay, as we discussed in earlier videos, that if you have a data points like this, okay, this is the data. If the model is very complex, it tried to capture the entire data, right? It tried to capture the entire data. Because of this the error increases. This is known as variance. Okay, so how this bias and variance are related to the underfitting and overfitting? Okay, so in underfitting there is high bias and low variance. Okay, in overfitting it contains low bias and high variance. So we must find a sweet spot between these two, that is balanced. Okay, that is medium bias, medium bias, medium variance. Okay, why not low bias and low variance? So it is not possible in the real life. Okay, it is impossible to find a balanced model where it gives low bias and low variance. It is impossible. Okay, so you have a bullseye. Okay, you have this type kind of Okay, so the high low variance and high bias, like you need to hit like here, but low variance you hit it like this is the the spread is low, low spread, low variance, but the distance is bias is high, high bias. Okay, and next when it comes to high variance and low bias. Okay, 1 minute. It's not working. Okay, yeah. Okay, okay, this is the bulleye. It's not, it is not looking okay. This is a bulleye. Okay, so here now with low bias and high variance looks like, okay, the spread is high, but the spread is high, but the bias is very low, like it only move the it is very near to the correct, like the correct assumptions, it is near to the correct assumptions. So low bias, high variance. Okay, high variance, so we need to find a spot where the bias is low and the variance is low, which is impossible, so we need to find which the bias is medium and variance is medium. Okay, we need to find a case where we need to, okay, this we need to find a spot like this where it contains medium bias, medium variance. Okay, so this is the bias variance trade-off. Okay, how it is related to the underfitting and overfitting, and how we can find the balanced so okay, how we can find the balanced model, how we can find the balanced model. So we have some techniques. Okay, we have some techniques like regularization. Okay, regularization it consists of L1 regularization and L2. L1 is known as lasso, L2 is known as rigid regression. Okay, these two are the which can find the some, it can prevent from overfitting. Okay, so what is and then other things like bagging technique we will be using, we'll be learning in upcoming videos, and boosting techniques. Okay, boosting techniques like ada boost, exi boost, and other boosting techniques which can find the balanced model where the where it contains medium bias and medium variance. Okay, so this is a short video about the bias variance trade-off. In next video we'll be learning what is mean by regularization. Okay, it is a very fun topic, like it's a very interesting topic. Okay, how we can add error, by adding error how we can reduce the error. Okay, so this is the just a small video about the bias variance trade-off and how it is related to the overfitting and underfitting. And okay, in next video we'll be discussing about lasso regression and rigid regression. All right.